Hello, I'm Brian Schmidt at Australian National University, and it's my great pleasure to have Neil deGrasse Tyson here with us at the ANU here in Canberra. So Neil, you and I go way back to 1994, when we wrote a paper together from my thesis, which had a very long title, but essentially it was measuring a very distant supernova. Now, from my memory, you used to spend a lot of time down at Cerro, where I spent a lot of time, and used to often take...
In Chile.
Down in Chile.
Of Chile, yeah.
Yeah, so you would take images for the supernova team down there, and this paper, I remember you being very fussy, which is a compliment to a scientist, and that was the first paper where we were really measuring distances beyond the local neighborhood. And it got me thinking about going all the way to measure what I thought was going to be a decelerating universe. So one of the interesting things that when we talk about science is we always refer to it in not technical terms, but everything we think about in science is underpinned by measurement, by precision. How do we actually get that idea across to the greater world?
Well, as Logan Clendenning once noted, no science achieves maturity without a system of measurement that's in place. And so you can go around, that's why early psychology had such great challenges. How do you measure the state of someone's mind? And you have, Freud wrote a book on the interpretation of dreams. Are these measurements or what? If you can't measure it and at the limit of that quantify it, it becomes hard to assert that you actually have a true understanding of what's going on. It's hard, it's not impossible, it's just hard. So back in the day, we're measuring everything we can about these stars that are exploding in the distant universe. And fortunately, they're bright enough so you can see them in the distant universe. And I was fun to be a minor author. You call me co-author. No, I was a minor participant in your project, happy to supply data to help you make the light curves, of course, of the supernova. My favorite part of that paper was to recognize that this exploding star is so far away in the universe that its light has been fundamentally affected by the expansion of the universe, and that the light curve has actually been stretched out over time, and you have to correct for that to match it with light curves of local supernova. And I think it may have been the very first paper to demonstrate this. Yeah. But it was expected. If we didn't get that, that would be a whole other kind of result. It was expected, but no one had measured it before. So I think in school curricula, part of it, yes, you got to learn what science is and how it works. A whole piece of that has to be that you really don't know anything unless you can measure it.
So, one of the things that I reflect on is that you say you were a minor player, but science is built up by lots of minor players, and people win Nobel Prizes when they happen to be the last minor player. The things that underpin the accelerating universe go from all those measurements you made in your thesis. And I was talking to Nick Sunseth, who reflected on when you were taking all those data, and that was the data you took underpinned this great experiment. Do you find that young people or old people around the world really get the idea how they can make a difference?
I think the people who understand science and want to become scientists, not so much because they read the highlights of discoveries, that can seduce some people into being scientists, but those who ultimately become scientists have learned along the way that at some point you have to love the questions themselves, because the answers are not coming to you daily or weekly or monthly or even annually. They may come only once in your lifetime. And along the way is the journey of exploration. And so yes, I'm taking data as for a couple of stars as part of a larger project that's being assembled where there's a bigger question getting asked. And if you do not love the active data taking, the daily grind of it possibly not working and then you have to fix it, or having corrupted data. I was on the mountain one time getting data, getting spectra of a star, and there's an earthquake. And the spectrograph shifted, but we didn't know this. Okay, we went to emergency power. We started taking data, and none of the data made sense. And you go one bit by bit, and then you find out, oh my gosh, the spectrograph went out of alignment. But suppose we didn't realize that. Suppose it was an earthquake during the day, and we're not there at the telescope, and we try to interpret fundamentally flawed data. That's a problem. Yep. These are part of the challenges of being a scientist, and you have to learn that that's part of why you love doing what you're doing. And so to foster an educationally literate electorate, where some of them might then become scientists, people have to learn not all of it is sunshine, blue sky, Nobel Prizes, A. B, most of the time you're going to get the wrong answer, and you might not even know why. And C, the act of failing is the indication that you're on the frontier. Yep. The day you make no mistakes is the day you have taken the low-risk path to nowhere.
So,
by the way,
okay.
not to beat this to death, but if you have a government that has policies that does not understand the role or value of a failed experiment, yep, then it will never be on the frontier of anything. And entrepreneurs know this. They invest their savings, the money from investments from venture capitalists, and even venture capitalists know it could fail. And if it fails, it doesn't mean you're a bad person. It just meant you had creative ideas that you were testing. And these are the engines of growth economies, if you want to take it to that extreme.
Okay, so actually thinking about that, here at ANU, we've invested in a big technical center that is allowing us to test and do things like CubeSats. So you're involved through the Planetary Society through a specific kind of interesting CubeSat experiment, which ran last year, and light sail. Light sail. So an interesting idea. So we actually were one of the ground links for that, although in a minor way. We're hoping to be a much bigger, partner next year. Why light sails? So that's an entrepreneurial thing. What are you trying to do in something that could easily fail?
Yeah, just as a reminder to people who if you didn't know, CubeSat think of that. It is a thing, but think of it more broadly as accessible access to space, to Earth orbit, and the spacecraft you can build it on a laboratory bench. And you can ask questions of the space environment, design experiments, attach it to this volume that has a prescribed mass and capacity to resist temperature and shaking. And then you can have students for senior projects or master's or PhD projects have access to space. It's brilliant. And so it's democratized space exploration scientifically, or even from the business perspective. So the Planetary Society, founded 35 years ago, co-founded by Carl Sagan and two colleagues of his. I now serve on the board. I was very honored to be asked to join the board within a year of Carl Sagan having died. And so this was like, is the pressure on or what? to fill some shoes there, I don't know. But the Planetary Society was the lead partner in an experiment to see if you can accelerate a spacecraft just with the pressure of sunlight. It's called light sailing, and it's a literal analogy to sailing. If you're going to sail towards a source of light, you're going to have to tack into it the way a sailor tacks into wind. And it's an exploration of a cheap and effective means of accelerating in space. It's propulsion, essentially. And so while it's a test case, it had certain milestones that it succeeded at, and we hope maybe it'll open up a new pathways for people to get around the solar system and beyond.
Well, it's one of those things that we hope to be able to join you in, I guess, next year.
And you might even have some power to make that happen.
Well, we're,
Mr.
yes,
Vice Chancellor.
as becoming the head of the university next year, we'll have a lot of power. So one of the things we do here at ANU is we do massively online open courses through edX. I've and Pope Francis have done 36 lectures on everything.
Excuse me, I and Pope Francis. There you go.
One of the things that we're doing right now is Charlie Lineweaver is doing one on Are We Alone? And so, are we alone?
Yeah, so generally when people say to themselves they're alone, they're not considering that there might be microbes living on their skin or in their digestive tract. Because if you want to include them, then you're definitely not alone. There are more microbes in 1 linear centimeter of your lower colon than all the humans who have ever lived and ever been born on Earth. So you're outnumbered by others who are just sharing even your own biological form. So typically when people ask, are we alone, they mean other intelligent life.
Other intelligent life on other planets. Forget our, let's move beyond.
Sure. Are we alone in the universe?
Yeah.
And it presumes that we understand intelligence enough to rank ourselves among others in that category that we might discover. And that's, for me, a debatable question. But let's take it as a given that we are intelligent and we're looking for other species with whom we can communicate. We've yet to find any, of course. You would have known about that by now. You would not have to come to this interview to learn if that were the case. But no, we haven't found other life, and we're still not sure how we would. So we've got radio communication technology. The good thing about that, of course, is that it can penetrate obscuring gas and dust in space. In the same way radio waves make it into this building, it can move through walls. Radio waves have high penetrating ability, unlike visible light or other forms of light even. So we send out a signal using radio waves, or we use radio telescopes, as what will soon happen if it's not already here in Australia, to eavesdrop on signals that may be sent our way. But here's an interesting challenge. We surely would have considered ancient Rome a civilization of intelligent people. But had aliens tried to send radio waves to them, no way to receive it, no way to send back, no way to even know what a radio wave is, because the technology had not yet been invented. So our definition of are we alone has to include the fact that they are not only intelligent, but have technology that they can invoke to then send signals across the galaxy. Now, we've only been able to do that for maybe 70 years or so.
Yep.
So, and most of our original signals that have been sent from Earth were quite by accident. Leakage from early television shows. You know, I Love Lucy.
Yeah, I was going to say I Love Lucy, boy.
And the Honeymooners, and maybe some early Howdy Doody. You know, these are the emissaries of our civilization as we go forward. The first wave of radio communication that would be received by aliens, intelligent aliens in another planet. So watch out for that. Who knows what they're going to think if that's what they're decoding? Because you can't send a signal that we know of faster than the speed of light as radio waves would be sent. So here's my concern, that maybe there was an attempt to communicate with us before we had radio waves. Yeah. And they concluded that there's no sign of intelligent life on Earth. Suppose, not only that, they figured out a cleverer way to communicate than radio waves and radio telescopes, a way that we have yet to invent, because we've only been at it for 70 years. They would still come back with no signal from us. So it's hubristic to even think that what we invent out of the human mind would be the way they would attempt to communicate with us.
So we're not sure if we're alone, and it's going to be damn hard to figure it out.
So no, I would say we're probably not alone.
Yep.
And it's going to be damn hard to figure it out. And I say we're probably not alone because just of how long the universe has been around, how many stars there are in the galaxy, and how many galaxies there are in the universe, and how common the ingredients of life are in the universe. We're not made of rare stuff. You know, if we were made of like an isotope of bismuth, then you could argue that this is a rare thing we got going here on Earth, and it's precious, let's not take it for granted. But we're made of carbon and nitrogen and oxygen and hydrogen. This is like the most common ingredients in the universe, and they're highly chemically active ingredients to boot. So what is the most complex expression of chemistry that we know? It's called biology. And if biology is an inevitable trajectory of the experimentation that happens naturally on planetary surfaces, then maybe life is inevitable, but is intelligence as we define it inevitable? Not much evidence of it in the fossil record other than us, kind of because we defined it. Maybe if whales defined intelligence, we would not be included in their definition, I don't know. But so these are fascinating questions that require that we relax the bias that we have as being humans on this planet, just to even ask the question in an answerable way, are we alone?
Well, Neil, thank you very much. It is great to finally have you in Canberra, and
it's great to actually finally meet my co-author from 20 years ago.
Yeah, it's great.
It's rare in our field to go so long without, we're not that big field, a few thousand of us. So, but it's a great honor to be on a paper with you, and congratulations on the Nobel Prize. And the astronomers win it maybe once a decade. It usually goes to the physicists. So it means every now and then people do recognize that we do something good in the universe.